This is USACO 2024 December bronze. Problem 3 is MOOIN time. Let's understand the problem first. Farmer John wants to find all possible moos in the contest string. The string length is n. A moo is a substring of length 3 in the form ci, cj, cj, where ci is not equal to cj. So something like moo, baa, cqq. If a moo appears at least f times, it is considered valid. However, the string might have one corrupted character, so we must consider all possibilities where changing at most one character could make new moos appear. The task: print the number of possible moos after considering a single possible corruption. Print all such moos in lexicographic order. The naive approach: if we change one character, we have 26 possible replacements. For n positions and 26 letters, total possibilities will be n times 26. For each modified string, we scan all substrings of length 3 to count moos. So it is O(n) per check. So the total time is O26 times n times n. This is too slow, for n equals 20,000. If we write Python-like pseudocode, which is inefficient, we use a for loop to choose position to modify, and then we use a nested for loop to get a character from 26 letters. Then we change one character by this letter. We check all substrings of modified string. The key issue of this solution is we can recompute everything from scratch for every modification. There are many repeated calculations. Now let's look at the optimized approach, which can get the full credit. We notice something important. Changing one character only affects 3 substrings: the one starting 2 positions before, the one starting 1 position before, and the one starting at the position itself. Look at one example. The original string is A, B, C, D, E, F, G, H. We change character C to X. Affected substrings will be ABC, BCD, CDE. After change, the string will be ABX, BXD, XDE. So we first count all moos in the original string. For each position, temporarily remove counts for the 3 affected substrings. Replace the character with every letter A to Z. For each new letter, add counts for the 3 affected substrings. If count is greater than or equal to F, record the moo. Restore the original character and counts. Now the complexity is n positions times 26 letters times constant updates, 23 substring. So it is OA times n equals 26 times 20,000 equals 520,000 operations. which is fast enough. The algorithm steps. Step 1. Initialize counts of all existing moves in the string. Second, define helper functions. Check move function. It is going to check if substring si is a move. Update point. This function is going to add or subtract 1 from move count at position I. Update range. This function is going to apply update point for positions I-2, I-1, and I. Step 3. For each character position, remove current contributions. We use the function update range. Try all 26 letters. Insert new contributions. Use function update range. Check if any move reaches F. Remove new contributions, still calling update range function. After the loop of 26 letters, we still need to restore original letter and contributions. Step 4. Connect all moves that meet the frequency requirement. Step 5. Output sorted list. The key insights of this solution: the locality of change. A single character affects only 3 substrings, not the whole string. Efficiency trick. Instead of recalculating everything, just adjust the differences. And the data structures. Use map or dict for counts. Use set for sorting unique valid moves. Sorting. Required at the end for lexicographical output. The complexity for this solution is O A times N, which passes comfortably. Now let's look at the C++ implementation. So include the header file first using namespace and then its main function. In the main function, we get fast input of N, F, and S. And then we define the map variable OCC. And then we define the set ends to store the result. We have the function check move. In this function, we will check whether the substring is valid. The next function is update point. We will check maybe the contribution of the current point. And then we have the function update range. In this function, we will check the 3 points. 2 positions before current, 1 position before current, and the current position itself. Then we will do the initial counts by a for loop. In this for loop, we call update point to check the contribution of all the characters in the original string. Then we will try all modifications by the for loop. In this for loop, we iterate through the original string, and then we try to update each character by 26 letters. And after we replace 1 letter, 1 character, we only check the 3 affected substrings, not the whole string. And finally, we output the size of the answer. And together we output all the moves.